This video is intended to cover our flipped classroom day for the 4.6 permutation lesson. We will be doing some problems out of your textbook, so it would be helpful if you paused the video and got your textbook out to be able to follow along in lesson 4.6. We're going to start on page 297, number 1. This one says, suppose that the kindergartners are gluing pictures of 4 different shapes in a line. In addition to a square, triangle, circle, and a star, they may also use a diamond and an oval. How many designs are possible? I'm going to start by just kind of drawing out our 4 different blank lines for the 4 different shapes that we're going to be gluing in a row. They have a square, triangle, circle, star, diamond, or oval that can go into that first choice. So you have 6 different shapes that can go in the first spot. And now you've used one of those shapes. And so whatever shape you used doesn't matter, but you only have 5 choices left for the next shape. And then 4, and then 3. When you start counting at a number and multiply down like we have here, this is actually what we call a permutation. So another way that we could write this would be 6 permute 4. In other words, you have 6 choices of different shapes that you can use, and you are going to select 4 of those shapes to be put in any order. When we do a permutation, we're saying that, for example, if you put a square, a circle, a star, and then a diamond. If you use those same shapes but put them in a different order, these would be counted as different choices for the kindergartners. So in a permutation, the order in which you select the objects matters. In other words, they're counted as different choices. You can see below in the definition that we have NPR, N permute R. The definition for that states that you're going to take whatever is listed as the N, take it factorial, divide it by N minus, this should be, let's just change that to a K really quick so that it matches with our notation. I apologize for messing that up. So if you have n permute k, then you'll have n factorial divided by n minus k factorial. So in our example above, we had we had 6 permute 4, which we could write as 6 factorial divided by 6 minus 4 as a quantity factorial. So this is 6 factorial divided by 2 factorial. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1, and so you'll notice that you could cancel out the 2's, cancel out the 1's, and you're left with 6 times 5 times 4 times 3, which is exactly what we did in the example before. In order to calculate permutations in your calculator, you'll first type in the n value. So in this example, you would type in the number 6, click on the math button, which is on the left-hand side right underneath your alpha. On the top, you would scroll over to PRB for probability, and that'll give you a menu listed. And you're going to look for NPR. Select that option, and then you'll type in the second value that you have, which for us is number 4. So we're going to try number 4 on page 298. I would encourage you to pause the video and try these on your own, and then come back and see what we've done here. All right, so hopefully you've paused the video and you've tried these on your own. Number 4, question A, asks us to do 6 permute 3. So if you're using your calculator, you're going to start by typing in the number 6. You're going to click the math button. Scroll on the top over until you see PRB for probability. Select number 2 for NPR, and then type in the number 3. You should get 120 for this one. Question D says do 6 permute k. Now, obviously, we can't type this one into our calculator, so you're going to be stuck using the definition. So you're going to do 6 factorial divided by 6 minus k as a quantity factorial. 6 factorial is 720, so if you would like to simplify this, you could write 720 divided by 6 minus k as a quantity factorial. Question E says do 9 permute 4. So same as before, this one has 2 numbers. You can type it into your calculator. You'll click 9, math, PRB, number 2, which is NPR. Type in the number 4. You should get 3,024. And then for I, we're doing 9 permute k. Similar to earlier, you will do 9 factorial divided by 9 minus k as a quantity factorial. 9 factorial is 362,880. So if you would like to simplify that, you can. Next, we're going to be talking about something called an anagram. An anagram is when you rearrange the letters in a word or a phrase. So we're going to start by looking at page 300, number 13, and we're going to talk about how many different anagrams there are for the following words. So the first word that we're going to look at is triangle. Notice that in triangle, all the letters are different. There are no repeated letters. So in triangle, you're going to count the number of letters that you have. So we have 1, 2, 3, 4, 5, 6, 7, 8 letters in the word triangle. There are 8 places that you can put each of the letters. So if you're thinking about kind of filling in the blanks, you have 8 choices for that first letter, and then 7 choices for the next letter, 6, 5, all the way down until you get to number 1. So 8 permute 8 is the same thing as 8 factorial. And 8 factorial or 8 permute 8 is 40,320. So we're just moving the letters around. We're not guaranteeing that it's actually going to make a real word. In question B, this gets a little bit trickier because you'll notice that you have some letters that repeat. So the L repeats. Now, this is going to seem silly, but let's say that all the L's were considered different. Then in this situation, this identifying gullible would be different from this one. But that's not the case. If you were going to swap your 2 L's in this word, it would still give you the same word. So we need to remove the possibilities of swapping 2 numbers and giving swapping 2 letters and giving the same word. So the first thing you're going to do is count how many letters total, just like you did with triangle. So we have 1, 2, 3, 4, 5, 6, 7, 8 letters here. And we're going to divide out all the repeats. So in this case, we have 3 L's. So we're going to divide out 3 factorial. Factorial because you can rearrange those L's in any order. So the 3 L's could go in any of the 3 spots and give you the same thing. This would give us 6,720. Next, we're going to look at page 301 through 302. We're going to start with number 4. So number 4 says, in a class of 200 students, how many ways are there to choose a president, a vice president, and a treasurer? So for example, if student A is the president, student B is the vice president, and student C is the treasurer, That would be different from A as the vice president, B as the president, and C as the treasurer. So the order in which we select the students for president, vice president, and treasurer is going to matter. It gives us a different identifier for president, vice president, and treasurer. So we're using a permutation here. You have 200 students total, and you're selecting 3 of them for those 3 positions. So we're doing 200 permute 3. 200 permute 3 is 7, 8, 8, 0, 4, 0, 0. At any point in time, feel free to pause the video and try any of the following problems on your own, and then watch the video to see how you did. Question 5. Consider all 2-digit numbers. How many 2-digit numbers have all different digits? So here's a 2-digit number, and we want the digits to be different. Now this is a little tricky. If you had a 0 as the first digit, this actually isn't a 2-digit number. This is the number 9, for example. So this is a 1-digit number. So in order to actually have a 2-digit number, this first digit cannot be a 0. So there are 9 choices, 1 through 9, for the first digit. The second digit can be a 0, but it cannot be the same as the first digit. So you would, if you could have a 0, you would have 10 total options, but it cannot match the first digit. So you take away one of those choices. So you have 9 times 9 for this one, which is 81. Question B says, how many 2-digit numbers have repeated digits? So once again, you cannot have a 0 as the first digit. And if we're talking about repeated digits, then that means that the second digit could also not be a 0. So you could have, for example, 1, 1, 2, 2, 3, 3, all the way through 9, 9. And there are 9 choices for that. In this problem, they ask us to identify the non-repeated digits as dull and the repeated digits as funny. So there are 81 dull numbers and there are 9 funny numbers. Question C says, there is a big bag with many pieces of paper inside. On each piece of paper, there is a 2-digit number. All of these numbers are different and all possible two-digit numbers are in the bag. If someone takes out a piece of paper from that bag, is it more likely to be a dull number or a funny number? So in this case, it is more likely to be a dull number because there are more dull numbers than funny numbers. We're going to do number 6, but we are only going to look at how many dull numbers there will be. So in number 6, we're taking a look at 4-digit numbers. So we're going to do 4-digit dull numbers. So as a reminder, a dull number means that you cannot repeat any digits. So in this case, if we have 4 digits, similar to before, you cannot have a 0 as your first digit. So you have 9 choices of digits for that first entry, 1 through 9. Because we cannot repeat, the next digit could be any number 0 through 10, but it cannot be the same as the first digit, so there are 9 choices here. The next digit could be any number 0 through 10, but it cannot match the first 2, so this has 8 choices. And then similarly for the last one, we have 7 choices. So this part right here is 9 permute 3. So in total, there are 4,000 536 dull 4-digit numbers. Question number 9. Question number 9 says, how many anagrams does each word have? So the first one says AGH. None of these letters are repeated, so they can go in any order. This would be 3 factorial or 6. So there are 6 anagrams. B says AHA. Similar to before, you're going to do 3 total letters. The A's are repeated, so we have 2 A's in this problem. So 3 factorial is 6, 2 factorial is 2, so this is 3. There are 3 anagrams in question B. Question C says, how many anagrams are there for AAA? This might seem like a trick question. If you wanted to continue the pattern from before, you could do 3 factorial. There are 3 letters, and all 3 of them are repeated. So there is 1 anagram. In other words, no matter how you rearrange those, it's always going to be listed as AAA. So there's only 1 anagram there. Question 10, how many anagrams does each word have? I would encourage you, since we've done some anagram problems, if you haven't already, pause the video, give this one a try on your own, and then come back and watch the video. Question A says John. John has 4 different letters and they are all different from each other. So that's 4 factorial. And 4 factorial is 24. Question B says Jill. Jill has 4 letters and 2 of them repeat, the L's. This is 12. Question C says peep. There are 4 letters. This one's kind of tricky because you have 2 P's and 2 E's. So we have 2 P's that repeat. We said and 2 E's. So and means multiply. So you've got 2 factorial times 2 factorial in the denominator. This is a total of 6 anagrams. Question D says eek, E-E-E-K. 4 letters, 3 of them repeat. There are 4 anagrams here. And then question E says R-R-R-R. So similar to above, 4 letters, all 4 repeat. There's 1 anagram. Question 11, banana. Banana has 6 letters in it. You have 2 N's and 3 A's. So 3 A's, 2 N's. This should give us 60. Balloon. Balloon has 7 letters in it. 2 L's, 2 O's. This should give us 1,260 anagrams. Boring is the last word that they give us. Boring does not have any repeats, so this is just 6 factorial. And 6 factorial is 720 anagrams. The next thing that we're going to look at, or the next example we're going to look at, has to do with a little bit of probability. So probability, by definition, is the chance that something is going to happen. It's always a number defined between 0 and 1. 0 means it's impossible. 1 means it's certain. You can kind of see a visual there of some different choices or some different examples. We're going to take a look at page 303, number 19 out of your textbook. Number 19 says, Jim rolls 3 number cubes. When they say number cubes, they mean a die. So Jim is going to roll 3 dice. What is the probability that at least 2 of the 3 numbers showing are the same? So let's talk about this. When they say at least 2, that means that either two of the dice could be the same, or all 3 could be the same. Having all 3 dice the same is actually the easiest. So if all 3 dice are the same, there are 6 choices for that. There's 6 sides on the cube. You're selecting one of those sides, and all 3 of them have to be exactly the same. So there are 6 ways to make that happen. For 2 of the dice to be the same, first we have to figure out which 2 dice will match. So either the first 2 could match, or the last 2 could match, or the first one and the last one could match. So there are 3 ways to select the 2 matching dice. And the matching dice have 6 options, 6 sides on the cube. And then the third die, the one that does not match, cannot match the 2 die from before. So you would have 5 choices for that third die. So for example, we would have 6 choices for that first die. If the second die matches the first one, there's really just only 1 choice for that. So it's like 6 times 1. And then there would be 5 choices for the last die. It's just one example. When we say the word or, we need to add things up. So you're going to take 3 times 6 times 5 plus 6. You should get 96 total options. Now this problem is specifically asking us about probability. So probability needs the chance that something will happen. So we're going to need to divide by the total number of options here. So if you didn't put any restrictions on these die, you would have 6 different options for the first die, 6 for the next die, and 6 for the last die, or 6 to the third. And that would be 216 total number of rolls using 3 dice. So for probability, you're going to divide these two. So 96 divided by 216. We're going to get 0.444, or another way of saying that is that there's a 44.4% chance of this happening. Question number 24. How many different anagrams are there for the word Mississippi? So Mississippi has 11 letters in it, 11 total letters. The I's in Mississippi, there are 4 I's in Mississippi. There are 4 S's in Mississippi. And there are 2 P's. So you're taking 11 factorial divided by 4 factorial times 4 factorial times 2 factorial. And your final answer should be 34,650. Question number 26. There are 10 digits from 0 to 9. You are going to select an ATM PIN. The rules for that PIN differ from bank to bank. Assume that no valid PIN can have repeated digits. For each length given, find the number of possible ATM pins. So for part A, it says we're going to do a 1-digit PIN. So in this situation, they are going to allow 0 to be digit for the first number because you could type that in as your first number in your PIN. So you would have 10 different codes or 10 different PIN numbers if you only had one digit that you were working with. Question B asks for a 2-digit number. Well, you have 10 different digits you could select for the first one, and we're not allowed to repeat digits, so then you would have 9 for the next one. Another way of thinking about this would be 10 permute 2, 10 digits and 2 places to put them. We're using a permutation because the PIN number, for example, 1, 2 would not be the same as the PIN number 2, 1. A 3-digit PIN, we would have 10 times 9 times 8. Or another way of thinking about that, 10 permute 3. 10 permute 3 is 720. A 4-digit PIN, you're probably getting the pattern here, 10 permute 4. A 5-digit PIN, 10 permute 5. Question F asks us for a 10-digit PIN. 10 permute 10. And then question G says an n-digit PIN. So in general, you could do 10 permute n, as long as n is at most 10 and an integer. If n is greater than 10, you're not going to get any pins, because you wouldn't be able to have different numbers if you needed, for example, an 11-digit PIN. You'd have to repeat something. Question 27, our last one for this video. There are 26 letters from A to Z. You want to select an ATM PIN consisting of 3 letters. Assume that no valid PIN can have repeated letters. For each length given, find the number of ATM pins. A 1-letter PIN. So very similar to the last one. We're going to have 26 letters, and we're selecting one of them. A 2-letter PIN, 26 permute 2, which in this case is 650. A 5-letter PIN would be 26 permute 5. A 10-letter PIN, 26 permute 10. A 26-letter PIN, you could either write 26 factorial or 26 permute 6, or sorry, 26 permute 26. Or an n-letter PIN, 26 permute n. Same as before. This works if n is less than or equal to 26. If n is greater than 26, then there are no pins that will work.